You're so dumb. Oh my god.
I'll hold it for you.
Are you serious?
Seriously?
This kid.
Alright,
Am I talking? I'm going?
yeah?
Right now? This is so sad.
Alright, talk louder.
Alright, so we have. In physics, there are two types of quantities. One is a vector quantity, which has magnitude and direction, and the other one is a scalar quantity, which has only magnitude. Okay, and here in physics, we also have distance versus displacement in kinematics. Distance is a scalar quantity, and it's the total distance traveled, while displacement is the distance from the start to end. And then we have speed, which is also a scalar quantity. Speed is the change in distance over the change in time. Velocity is a vector, and it is the change in displacement over change in time. And finally, we have acceleration, which is the change in velocity over time. Acceleration is a vector. And now we have position versus time graph. The slope of a position versus time graph tells us the velocity. And we have a velocity versus time graph. The slope of a velocity versus time graph is acceleration, while the area is the change in displacement, or delta x. And then we have acceleration versus time graph, and the slope of that is a jerk, which we don't need to know. And the area is equal to the change in velocity. Now let's move on to 1D kinematics. We have several formulas now you can use for 1D kinematics. Velocity final is equal to velocity initial times plus acceleration times time. And you have delta x is equal to velocity initial times time plus half at squared. Vf squared is equal to VL squared plus 2a delta x. And depends on which, the formula you use depends on which variables are given and which ones you need to figure out. For 2D kinematics, the velocities and accelerations should be broken up into x and y components and then solved for individually. When an object is in free fall, the acceleration in the y direction is negative 9.81 meters per second squared. Okay, I think
Hi, I'm Newton, and my first law is an object at rest will remain at rest, and an object in motion will remain at a constant velocity unless acted upon by a net external force. Hi. My second law is F equals ma, and the force of gravity is F equals mg. When using my second law, remember to use a free body diagram, which is a diagram shows all the forces acted upon the object. My third law is for every force from object 1 to object 2, that's an equal but opposite force from object 2 to object 1, and both are vectors. Just like what you saw, it's actually me hitting the spiky thing. 10,000 IQ. And one application is a normal force, which is caused by a surface, and it's normal or perpendicular to a surface, and it's always a push. One application for a normal force is the friction. Friction is parallel to the surface, opposes motion and independent of the direction of the force applied. So the equation for friction is mu times F, the normal force. And the mu is the coefficient of friction, which has two different kinds of friction. One is static friction and one is kinetic friction. Usually the coefficient for static friction is bigger than the kinetic friction, which means it's harder to move an object at rest than moving an object while it's moving. In an incline, you need to break the force of gravity to its components. So the force of him sliding down is mg sine theta, and the normal force he applied, which is going this direction, is mg cosine theta. Yeah. Okay, so what you see right now is Swan in his static equilibrium. He's not moving at all. And soon, he'll transform into his dynamic equilibrium, where he will chase Ray in a constant velocity. Very constant velocity. Tangent force is a force of pulling. So I'm exerting gravity force on this thing, and the tangent force by this is preventing it. The fuck, Swan? It's preventing it to falling down. There's many types of energy. Work is one of them. Force times displacement times cosine is equal to work. And there's three types of mechanical energy. The first of the one kind of them is kinetic energy, which is equal to 1/2 mv squared, and it cannot be negative. The second one is elastic potential energy, which equals to 1/2 kx squared, and it also cannot be negative. The third kind is gravitational potential energy, which is equal to mgh, and this one can be negative. If the height is negative, this kind of energy can be negative. Okay. Both work and energy are scalars, and the conservation for mechanical energy is mv initial equals mv final. This is only true when no energy is converted to other energy, such as heat, light, or sound, due to friction. And if this friction and you need to use energy is equal to work final equals delta m times E. This does not work when there's a force applied, and not a force besides friction. Power is a way of which work is done or energy is transferred into or out of the system. Power can be equal to watts over delta T, or it can be force times V cosine theta. And 1 horsepower is equal to 746 watts, and this is how much power a horse can generate. For Hooke's law is equal to F equals Kx, which is force of a spring, which is linearly proportional to the displacement from its equilibrium position. The slope of a graph of a spring is force over displacement from equilibrium position is it's a spring constant, and the K unit is usually Newton over m.
Universal gravitations, and the Newton's universal law of gravitation states that force of gravity equals gravity times mass 1 times mass 2 over r squared, and the gravity here is 6.67 times 10 to the negative 11 newtons meter squared over kilogram squared, and the r here is the distance of the center mass of two objects, which is not the radius. And the universal gravitational potential energy for this is UG equals negative G m1 m2 over r. And if gravitational potential energy is less than or equal to 0, that means the r is infinitely big, so which is make it into 0. Yeah, that's the first topic. The next The next topic I'm doing is electrostatics. So 1 electrons is equal to 1.6 times 10 to the power of 19 coulombs, and the electrons is equal to So the electrons is equal to negative E, which is equal to negative 1.6 times 10 to the power of 19 coulombs, and it is a fundamental particles. And 1 proton is equal to 1 positive electrons, which is 1.6 times 10 to the power of 19 coulombs, and it is not a fundamental particles. Notice that electron is less mass, which means that the electron will accelerate faster toward proton when they are put together to each other, even though they experience the same force. The Coulomb law stated that force of electron is equal to K Q1 times Q2 over R squared, and the K is equal to 8.99 times 10 to the power of 9 newtons meter square times over Coulomb square. Notice that this is very similar to Newton's universal law of gravitation, which is Fg, force of gravity, equals gravity times mass 1 times mass 2 over r squared. However, since K is equal to 8.99 times 10 to the power of 9, and gravity is equal to 6.67 times 10 to the power of 10 to the power of negative 11, which means that K is force of electrons is 10 to the power of 20 more than the force of gravity. Conservation of charge stated that in an isolated system, total charge remains constant. For example, when Q1 equals 4C and 4 coulombs, and Q2 equals negative 2 coulombs, so when we touch them together and Q1 and Q2 just touch each other, they will become 1 coulombs, which also end up with 6.4 times 10 to the power of 18 excess proton. For the electric potential difference is equal to Q, delta V is equal to delta potential energy electrical over Q. So which means that the equation could be delta V equals IR, or I equals delta V over R, or R equals delta V over I. So it is equal to V over amps equals ohms. So there's 3 kinds of circuits for the wires thing. So no, hey. Okay, there's 3 kinds of circuits. The first one is series circuits. So it uses, how do you pronounce this? Ooh. Okay, there's 3 kinds of circuits. The first circuit is the serial circuit, which means the total current is equal to current 1 and is also equal to current 2. For the potential difference, which is delta V, is equal to V1 plus V2. The equivalent resistance is equal to R1 plus R2. In order to find the R equivalent, is basically just equal to R1 plus R2 plus R3 plus R4 and so on. And the other one is the parallel circuits, which means that the potential difference, the delta V, is not equal to V1 plus V2. Delta V is equal to V1 and is also equal to V2. For the currents, the total current is equal to current 1 plus current 2. And for equivalent resistance, is not R1 plus R2 anymore. It's equal to 1 over R1 plus 1 over R2, and the equation is to the power of negative 1, and that's the equivalent resistance. For the electric power is the rate at which energy is dissipated in circuit elements, and the equation for that is P equals I delta V. I times delta V is also equal to I squared over R, or is also equal to delta V over square over R. And for the combined circuits, it's just a combination of parallel circuits and series circuits. And this is a small example that I did. So we can see that for the parallel circuit, we just add it up and use the equivalent resistance to find the R1, R23. And for this, we just add it up to find the total R, which is R equivalent. And since we know the delta V and R resistance, we can find the I total, which is 2.678. Yeah, and that's combined circuit. Done. Yeah.
Momentum is a vector quantity. Momentum is also represented by the equation P is equal to mv, where m is mass and v is velocity. The dimensions for momentum have no special name. It's just kilograms times mass over seconds. The greater the mass that an object has, the greater momentum it has as well. The greater velocity that an object has, the greater momentum that it has as well. And momentum is conserved in all collisions. Goddamn plane. There are three types of collisions: elastic, perfectly inelastic, and inelastic. In all collisions, momentum is conserved. However, only in an elastic collision is kinetic energy conserved. In perfectly inelastic and elastic collisions, kinetic energy is not conserved. The difference between perfectly inelastic and perfectly inelastic collision and inelastic collision is that in perfectly inelastic collisions, the two objects that collide stick together, while in an elastic collision, the two objects separate after collision. If you rearrange Newton's second law in terms of momentum, you'll find the equation change in P is equal to the summation of force times change in T, which is also called the impulse, represented by the letter capital J. The impulse is given on the equation sheet, and on a force of impact versus time graph, the area between the curve on the time axis is impulse. The dimensions for impulse is, again, kg times m over seconds. Okay. Much of rotational motion can be applied and transferred from linear motion. Torque, which is essentially rotational force, has the ability to cause an angular acceleration of an object. Torque is represented by the equation moment arm times force. The moment arm is represented by R, and force is represented by F. You can maximize torque by maximizing R, or the distance from the axis of rotation to the force. The dimensions for torque are Newton meters, which is not to be confused with joules. And torque is also a vector, just like forces. Another formula for torque is Newton's second law has a rotational formula, which is that torque is equal to the moment of inertia times alpha, which is the angular acceleration. The moment of inertia, or rotational mass, for a system of particles is equal to summation of m times r squared. The dimension for moment of inertia is kilogram times meter squared. For a rigid object with shape or value, the equation will usually be given to you. So, for example, for a cylinder, it will be half mr squared. For a thin hoop, it will be mr squared. For a solid sphere, it will be 2 over 5 mr squared, and so forth. And rotational kinetic energy is essentially the same as linear kinetic energy, where kinetic energy is equal to half mv squared, but in the case of rotational motion, it's half I omega squared, where I is the moment of inertia and W is
Omega.
goes without slipping down a hill, it will gain translational kinetic energy or linear kinetic energy, but also rotational kinetic energy. Which means the higher the moment of inertia, the higher the rotational kinetic energy of the object, and therefore the lower amount of energy that will be left over for translational kinetic energy, and the lower final linear velocity. So if you use conservation of mechanical energy, you can solve for both the rolling momentum, the rolling kinetic energy, and the linear kinetic energy. The angular momentum, L, is represented by the equation L is equal to I times omega, where I is the moment of inertia and omega is the angular velocity. Dimensions for angular momentum is kg times meters squared over seconds. And angular impulse is the change in angular momentum, which is represented by torque times the change in time. Yeah, that's it.
Simple harmonic motion is caused by a restoring force. A restoring force is always towards the equilibrium position, and the magnitude is proportional to distance from the equilibrium position. The cycle for a spring or pendulum is from the upper limit to another upper limit. That's the entire cycle. That's one cycle of the simple harmonic motion. And the period of mass spring system is T equals 2 pi square root m over k, which is independent of amplitude and acceleration due to gravity. The period of a pendulum is 2 pi square root L over G, which is independent of amplitude and mass.
So the next topic I'm talking about is rotational kinetics. So the angular velocity equation is that omega equals delta angle over delta t, which is either radian over second or revolution over minute. So for conversion, one revolution is equal to 360 degrees, which is 2 pi radians. For the angular acceleration, is A equals alpha equals delta omega over delta t, which is radian over second squared. So there's two kinds of equations. One is uniform accelerated motion, UAM. So V final equals V initial plus AT. Or delta x equals V initial times T plus 1/2 AT squared. Or velocity final square equals velocity initial square plus 2a delta x. And another one is the uniform angular accelerated motion, U alpha m. So omega is equal to omega initial plus alpha t. Or delta angle equals omega initial times t plus 1/2 alpha t square. Or omega final square equals omega initial square plus 2a delta angle. And the centripetal force is equal to MAC. And it is not a new force, it's never in the free body diagram, and the direction is in positive and the direction out is negative. The centripetal acceleration is A equals V total square over R, which is equal to R omega square. The period is the cycle of revolutions. The opposite of period, which is 1 over T, which is equals to 1 in So the equation divided for the angular acceleration is omega equals delta angle over delta t, which is 2 pi radian over t, and t is equal to 2 pi over omega, which is 1 over f, which is similar to frequency c equals 1 over period. So also the velocity is equal to r over r times omega, which is the tangential velocity of an object. The velocity of the center mass of an object rolling without slipping is v over r, which is bigger r omega. The equation for centrifugal force acting on an object to keep it moving in a circle is F equals mac, which is A is in centrifugal acceleration.
Louder, louder.
That was constructive interference.
Yes.
Alright. A wave is the motion of a disturbance traveling through a medium, but not the motion of the medium itself. Disturbance of the medium is energy traveling through a medium. A wave pulse is a single wave traveling through a medium, while a periodic wave is many wave pulses at a specific periodic time intervals. The energy moves through the medium as the wave pulse. However, the overall displacement of the medium is zero. A transverse wave is the disturbance of the medium, and for a transverse wave, the disturbance of the medium is perpendicular to the direction of wave propagation. Longitudinal wave, the disturbance of the medium is parallel to the direction of wave propagation. And electromagnetic waves are transverse waves that do not need a medium to travel through. They are the only waves that we know of that do not need a medium. The distance between two successive crests is called the wavelength, or lambda. The time it takes for one full cycle, or for one full wavelength to pass the point, is called the period t. Using the equation for velocity, we can determine the equation for the velocity of a wave, where v is equal to frequency times lambda. And for simple harmonic motions, they don't have a wavelength, so you cannot use the velocity equation to find the velocity of a simple harmonic motion. Waves are not physical objects. They are energy traveling through a medium. Therefore, waves can occupy the same space at the same time. We determine their combined amplitude using superposition. Constructive interference is where waves are added together to create a larger amplitude, where total destructive interference have waves that cancel one another out to create an amplitude of zero. Okay.
A standing wave is a periodic wave that are reflected and inverted and interfere with one another, creating a standing wave. In null is location of the total destructive interference, where it's like zero. Anti-null is the location of the maximum constructive interference.
What the hell is this?
And the fundamental frequency, or the first harmonic, is the frequency of the first standing wave. The second harmonic is double the first harmonic, and that's only applies in the open pipe. For closed pipe, let's move on to Swan.
For closed pipe instruments is different from open pipe instrument, since the frequency is different, and the fundamental frequency or first harmonic of closed pipe instrument is 1/2 lambda equals L, or 1 lambda is equal to 4L. Or since velocity is equal to frequency times lambda, so the frequency will be V over lambda, or V over 4L. And for third harmonic is 3/4 over lambda equals L, and lambda is equal to 4L over 3, and frequency is equal to V over lambda, which is 3V over 4L. For fifth harmonic is 5 over 4 lambda equals L, so lambda is equal to 5L over 3. Since frequency is equal to velocity over lambda, so it's going to be 5V over 4L. And the overall equation for frequency is mv over 4L, and V can be all the odd numbers. That's the first part.
Oh, you've turned into a parabola. This is the children you see at Boston.
Yeah.
That's it. That's it. Go do your project, bro.
Okay, now let go and you'll become a projectile.
日本語わかりません What are you saying, bro?
Oh my god.
Come on, talk about it! He's gonna talk about it while you speak!
That's not. Is no one gonna talk about this?
Swan! What? Shut up! Talk about this! Bring us up here.